This is Engineering Mathematics 1. Before I start my class, maybe it's appropriate to state the grade policy. So, the most importantly, the A plus will belongs to top 10%. And during this semester, we might have about 2 or 3 quiz for up to 1 to 2 hours, and one final exam which is going to be 3 hours long. So 60% of the total grade comes from 1 to 2 hour quiz, depending on the occasion. Usually maybe 2 or 3 quiz. And 40% final exam. And there will be 1 or 2 unannounced surprise quiz during the semester, during the regular class hours. And you can check my previous lectures at the YouTube under my name. So my YouTube lectures can be found under Professor David An. And you can ask any questions, or maybe ask for the personal meeting through my email, which is dahn@us.ac.kr. So if you have any questions about this grade policy, then you can ask me through the email. So the first topic for this semester is linear algebra. It's a theory of matrix. Before we get into the details of matrix theory, I would like to state the basic rules of algebra. Arithmetics. The basic rules of arithmetics include addition, subtraction, multiplication, and division, or that can be represented by this plus, minus, multiplication, or times, and division. And set of numbers is called number system. Set of numbers with the common. So the first number system, and when the set of number system, given number system, is closed to the four basic rules of arithmetics. We say that system is closed. We say that system is closed to the arithmetic rules, basic rules of arithmetic. The first number system you probably learned is natural numbers. Set of natural numbers. Which is 1, 2, 3, 4, etc. So comprised of positive integers. Then obviously addition is satisfied by the natural numbers. That means the result of the addition of two or more natural numbers also belongs to the same set. And so is the multiplication. Is satisfied by the natural numbers. How about subtraction? We call this is n. 2 minus 3, it doesn't belong to natural numbers, right? And division. 2 divided by 3, it doesn't belong to natural numbers. Set of integers. So J is close to addition, subtraction. Subtraction, there are any two integers, also integers, right? And multiplication. But not division. So why the satisfaction of these four basic rules of arithmetic is important? because if we want to represent the functions such as sine x by Taylor series, we have x minus x cubed by 3 factorial plus x fifth by 5 factorial. So it does have a subtraction. This is multiplication. This is division. So that means we cannot represent sine x by only integers, right? Because integer is not close to the operation of division. The first number system that is close to the 4 basic rules of arithmetic operation is rational numbers. Q is divided by m, n. Both m and n belongs to J. So rational number system is, we say Q. So rational number system is the first set of numbers which is closed to 4 basic rules of arithmetics. Then real numbers and complex numbers follows the extension of the rational numbers. Turn our attention to the matrix. Matrix is defined as the following. Matrix. M is defined by A11, A12, A21, A22 are either real numbers or complex numbers. So my question is whether set of M satisfies 4 basic arithmetic operations. If they do, we call this is a linear algebra. So let's check addition. So definition of addition is the following. If A is A11, A12, A21, A22, B is B11, B12, P21, P22. And for most of our class, my class during this semester, we will be considering very simple matrix, so by 2 by 2 size of 2 by 2. So A plus minus B is A11 plus minus B12, B11, A12 plus minus B12, A21 plus minus B21, A22 plus minus B22. So each term by term will be either addition or subtraction. On the other hand, the multiplication of two matrices will be defined as the follows. A times B is written as AB, which is A11, A12, A21, A22 times P11, P12, P21, P22, which is defined as simple rule is the following. You multiply each element and add them together. So it's A11, B11 plus A12, B21. Next column is the following. A11, B12 plus A12, B22. And this is given by A21, P11 plus A22, P21. The final element is A21, P12 plus A22, P22. That's definition. On the other hand, B times A equal to PA is P11, P12, P21, P22. A11, A12, A21, A22 is using the same definition as follows. P11, A11 plus P12, A21. This and this. We have P11, A12 plus P12, A22. And third element, P21, A11 plus P22, A21. The final element is P21, A12 plus P22, A22. So let's compare these two numbers, first element. So A11, P11 is same as A11, P11, but the second element, A12, B21, may not be different, may not be the same as A21, P12. So we have the following result. In general, AB is not necessarily the same as BA. So in this case, we call this matrix multiplication non-commutative. So matrix multiplication is non-commutative or non-abelian, or sometimes called non-abelian. I'm sorry about this. Non-abelian. So this is different from the major difference between the matrix multiplication and the multiplication of numbers. So how about division? Can you define division process? For the matrices. So for example, 4 divided by 3 is the same as 4 multiplied by 1 over 3. And we call this 1 over 3 is inverse of 3. So if we can define the inverse matrix, A inverse of A, such that A inverse A inverse is identity 1 0 0 1, then we can define the division of the matrices. And this is only true for square matrix. True for square matrix. For example, if we have A11, A12, A21, A22, we call this is a row and this called column. So when the number of row is the same as the number of column, we say the matrix is in the square form. So let's consider some very simple cases. Say A is A11, A12, A21, A22, and if A11, A22 minus A12, A21 is non-zero, and define B as 1 over A11, A22 minus A12, A21, A22 minus A12 minus A21, A11. And let's consider AB, which is A11, A22 minus A12, A21 over times A22, A11, A12, A21, A22 times A22 minus A12 minus A21, A11, which is 1 over A11, A22 minus A12, A21 times this and this will be A11, A22 minus A12, A21. How about this? Minus A11, A11, A12, A12, A11, which is 0. And this is A21, A22 minus A22, A21 is is again 0. The last component, minus a12, a21 plus a11, a22 is to be a11, a22 minus a12, a21 by a11, a21 minus a12, a21, 0, 0, a11, a21 minus a22, a12, a21, and actually they cancel each other, right? So it becomes 1, 0, which is defined as identity matrix. So we can define a inverse as this matrix, a11, a22 minus a12, a21, a22 minus a12 minus a21, a11. You can check a inverse a. So I will give this as homework. For my homework, you don't have to turn in, just do it home. So homework means just do at home, but not submit. So today is the first class, so maybe I'll stop here today and then continue next week. Okay, have a